So this is I square R. I change the power of by controlling the I. So this is the way I control the I. When the resistor is become 0, then I get the maximum power. When the resistor is become infinity, I get the lowest power because I is 0. Then if the resistor is R, I get different power. That's why we do it. So we give. So that's the three. These 5. In this control we have switch and regulator. But practically people are doing it. Yeah, we have achieved everything. There is something wrong with this. What is wrong? When I have a mechanical, I have gears. When I turn this gear, based on the ratio N1, N2, this gear rotates. Based on ratio N2, N3, this gear rotates. So beauty is, I am moving only one gear, but the energy is getting transferred to, but they were very confused. I am putting this switch on in the bulb. This bulb is glowing. That's what it stops. I am not able to transfer the, here when I rotate, it is going all the places. The information is going all the places. In this case, I on this switch, this information that stops at the bulb. I am not able to do the transfer. Then only they have found out a very interesting device because of our man who Faraday. They found an interesting device. There is an automatic switch. Automatic switch. So the automatic switch is, they found it very simple. I have a magnet, electromagnet. We say father of computer is Charles Babbage. We are supposed to say the father of electronics is this device. But unfortunately people have not really understood the reality of how this device has changed the world. It will be a very small device. So when I apply here 5 voltage, then this thing is on. I give a voltage here. I connect a bulb. So bulb is going to be on. Okay. So now when this case is 0 voltage, this is off. This they call it as a electromagnetic switch. The trick was very simple here. See here, I have a battery. Here, see that? Same like this gear. I on this switch. This gear is on in this switch. And this power is going to on this. Things are passing on the other place. So the information at one place is passing on the other places. So we call this device as, because they thought that, you know that Americans, they are always too good in giving the names. So the naming is the beauty of them. So they named it as a super device. They find out what name they can give it. Oh God, this is like giving a stick in sports. I say that hey, you stand on the 4 corners. I give you a stick, you pass on, you pass on, you pass on. So they call this device as a. The name was given because it is relaying the information. It is relaying the information. Otherwise, you cannot find the difference. You cannot find the relation between electromagnetic switch and the relay. These two are totally different. But they were trying to push. This is sort of see, the thing is that we have a thing. Electronics is different. Electronic component is different. Electronics, people have understood electronics long time back, like physics, mechanics, everything. But unfortunately, they could not able to bring the electronics into reality. Because why they are not able to bring the reality? they could not able to invent an electronic component. So they were trying to do something. So this guy said, hey, I invented, I think his name is Robert. It's very mistake. I should have forgotten this. I have a big problem in forgetting the names. So I think I'll give you a name next. His name is Robert, I think. Something. So he is the one who invented this thing. He was fighting for this has to be called electronics component. He said no. Scientists said, you have introduced me a magnet. They say that this is electromagnetic component. If you don't have, always you have any mechanical or magnet, we cannot accept this as an electronic component. Then only our madness came in, who? Fleming. Because of thanks to our Edison. What Fleming did was, he did a very simple. He took the bulb. The bulb, we know that there is a filament. And this is vacuum. This is vacuum. So what Fleming did was, he cut the filaments. But unfortunately, if you cut the filament, what happened? Why bulb will not go? There will not be any current. But Fleming was saying that no, it's a vacuum. The electrons should flow. The electrons are coming here because of this force. It should flow through the vacuum. See, it was what, 1700 or 1800. Am I right? So he came to, because of Edison, he said. But you know the scientist, it takes very long time to do this finding. Then finally he found out 20, oh, very good. Even the electrons are coming, it's not able to come out of the material. So I have to give extra energy. Then the Fleming did a small change in this. Fleming did a small change in this thing. The same two wires, same way. But now, unfortunately, these electrons are not flowing. So what he did was, he added a small heater. When he added a heater, it was giving energy to the electrons. The electrons are coming out. Since it's a vacuum, this gear was attracting the electrons to start flowing. Since they called this as a cathode, it is called anode. Sorry, I think I have to find the explanation why they call cathode and anode. Normally I try to find the explanation for everything, but somehow I missed. Thanks, I tried to put it. This they call it as a diode, because two, di means two, and this was invented in the year 1904 by Fleming. And unfortunately, electronics people said, hey, you are heating and the current is flowing. Where is the control? You are not controlling anything. So they said that we cannot accept this as a part of electronic component. So diode is not officially electronic component. Then the people have worked for another 1 or 2 years, and they finally found out. They added a small metal piece called grit. Now what happened? This electron used to flow through this. They were happy. Then they asked, where is the control? The grit, when they apply minus 5 volt, whatever, it becomes negatively charged. And the electrons are going there. So this gets rippled. If we do more and more negative, what happens? More and more rippling. So it means that very less electrons are going at some voltage, maybe at 10 volts, they are going to be 0 electrons. That time it is going to be off. When I give here 0 volt, what happens? No control. Every electron is going to go through. So they finally found out this vacuum tube is nothing but a variable resistor. The varies from 0 ohm to infinity ohm. They found this is invented in the year 1906. This is called triode. So this is the first electronic component invented in the world was in the year 1906 by Fleming. Is the thing. It is nothing but same bulb with a thing called gate control. And this is next time I bring this. This time I forgot. Next time I bring the first vacuum tube radio. I have it at home. And bring a radio here, so that you will know that how these vacuum tubes are. Even I bring a vacuum tube itself. I've never planned for that, so I'll bring it next time, all those things. So we people should know enthusiasts. There were about four, you can divide the whole electronics into four. First one is called history. Second one is called invention. Third one is called development. Fourth one is called integration. So I was living in the forest. I never know how to live as a civil person. As a civilized person, I don't know how to live. Then I thought, it's boring. I should have a place to shelter to live. I invent how to build a house. Then I thought, hey, this is correct. But why 100 people are living in such a big place? I will build apartments. I will build that is development. I start building apartments. I was happily living. The civilization next stage is development. But then they found out, oh God, there is a big problem. If you have to construct an apartment of 100-story, it's not possible because it's going to fall. It requires a lot of cost. I have a land, it's fine. I will do one thing. I will make 10 100-story building. That's what people are calling it as a township. They build they say that integrated township. I have about buildings, I have theatres, I have a shopping mall, I have a school, everything they are placing. You take a Hindu paper, yesterday's Hindu paper, you will see ad. So that's called integration. In electronics, same thing here. Initially, history, up to electrical. Then first invention started in 1906. Then the invention stopped at 1947. The last invention happened in electronics was the year 19. After 1947, no invention in electronics. Things started doing development. The development stopped at 1970. The last development happened in electronics was in 1970. From that day onwards till today, electronics is the path of integration. That's why you are calling, as of today, the development was, they call it as a microcontroller first, then they are calling it as a SOC. Today they are calling the latest development of integration is called SOC. I put so many ICs inside the single chip, but ultimately everything here. So if you know this thing here, that's why we are discussing now. The problem is, without understanding this, if you go to the next one, somehow I am not correct. I feel that if you like to go bigger, better put some concentration on that, what happens exactly. So what is the thing behind all these things? So from 1906, things were going very well. This electron tube, I could do everything. And that time, the thing was, exactly coincidence happened. Margolin have invented the what? Radio. Through crystal radio, they did. At the same time, our man did a wonderful work. Who? He is the one who invented radio. That's the reason we call him as a frequency escalators, because even though electromagnetic waves are present in the world naturally by the sun, all the sun waves are electromagnetic waves, but still artificially how to create was invented by. So man-made electromagnetic wave transmission was created by Hertz. So when all these things were coinciding, very unfortunately one thing was missed. Thing was, when the signal comes from far away to my place, in the path, it lost its energy. You send us so much of higher voltage. When it comes to me, from X to Y, so I am in the position of amplifying the signal. So how to amplify? Then they found out, do one thing, like a lever. That's what people do it now. I push it here, this gave it Y. Am I right? I put X here, this gave put on Y. Same way here, what they have done, as a reason they do pulleys. They bring the biggest water and everything from the well and everything. Here they found out this vacuum tube. They give it the signal inside the grid. That guy is blocking the flow of electrons. Now this guy, you will try to get it out. How is it? We will see now. That's because this is a fundamentally we need to understand. As an electronic student, we need to understand this fundamental, how the amplifier works. We most of us have to understand how an amplifier works. That's very thing. Because we all know that we cannot create energy or destroy energy. So there's no way I can amplify an energy. But then how come amplifier works? Let's see here. What exactly he did was, let us say V. V is a signal is controlling this resistance of the vacuum tube. See, the problem is why I model this as a resistor is, what is the function of resistor? Is indirectly, as long as you fix the V, R, and I. So I can say I is equal to V by R. When V is fixed, if I is changing, R has to change. No way. If a V and I are fixed, V and R are fixed, I is going to be fixed. In this case, if you take a vacuum tube case, I am fixing the V. V is fixed. I am not changing the voltage. What I am changing? Changing the current. It means that the resistor is supposed to change. How much is changing? That we will discuss. So that is the reason we have got IP. So now what happened? I add one more resistor here. I apply 100 volts here. I apply how much voltage? 100 volts. And the signal comes here. This case, let us assume that I am giving a 1 volt here. That means this is, let us say, 1K. And this is 1K. This is 1K and this is 1K. What is the voltage I get here? That's why I said V is equal to IR is very, very important. Without that, I cannot discuss even the next term. Now, what is the voltage here? V naught. V naught is how much? 50 volts. Because it's get divided. I get 50 volts. Now, let us see here. I change the 1 volt to 2 volt. I am changing how much? 1 volt to 2 volt. Let us assume that this voltage is becoming, let's say, 0.5K. How much is giving? 0.5K. Or let us assume that this is going to become 2K. Let us take something. Okay, it is changing. It is changing, that's all. How it is. Now, when I am applying input as 2 volt, what is becoming is 2K. Now, what is the voltage now? Output voltage. Let us take this. Let's say this is I give for 3K. And easy for us to do it. I check it to 3K.
1/4 of.
Yeah. That's why sometimes suddenly what is the voltage out? What is V naught? 3K, what is V naught? What is V naught? Huh?
1/4 drops, 3 volt output 75.
75. It is 75. So please understand, make sure that we thorough on this. There's no way we proceed further. You should go to any courses or EDX or any MIT lectures, anywhere you say, they say only one thing. Please perfect voltage divider. If you do not understand voltage divider, you better forget electronics. You will not understand electronics. This circuit is the most vital. Voltage divider is the most vital circuit. We will discuss something else here. See. Now, previously 50 volts, now it has become how many voltage? How much I changed inside? Previously I have given, now how much I changed? 1 volt. How much is changed here? So the amplification factor is 25. Now we change this to 1000 volt. I change it to 1000 volt. What is happening? 500 volts and 750. This change it to how much? I didn't change the input signal. I didn't change anything. You said this resistor is changed from less than some 10K to 10K or something. Then the ratio will change. So the amplification is changed. You are actually amplifying the signal. You are not amplifying the power. So what happened? This guy is taking something from here and this guy is taking all the power from this guy. This guy is giving extra power for amplifying a signal. So please understand, this voltage divider acts as the amplifier. Amplifier is nothing but a voltage divider circuit. If you will understand, it's fine. Otherwise, we will discuss, we will take this is a one session topic. If we all have to be, that's what we should say, because how much we need to also do, we need to change that, how much we need to give stress on analog and digital and embedded. I normally my concept is, first I want to live today, which is going to be important for me. That is this. Okay. Then parallelly every day, every meetup, we spend some time to understand the history. Oh, what is this? What is this? We call everything history. Today analog is history. You need not have known about analog. If you don't even analog, you can work in analog industry. You go to all the analog companies, you don't have to know, you will not be good at analog. That's the thing. And if you don't know digital, then you can very well work on any digital company. If you don't know anything about electronics, you can work on any electronics. These are reality. Please understand, let us go with the reality. If you say that I don't know electronics, you are welcome by the electronic company. If you don't know, I know about analog, you are welcome by the analog company. If you don't know about digital, you are welcome by the, because things have changed. Today, the whole industry is working on something different. That's what we will discuss. Okay? So, actually there is another company which is, we have a break or something. Other company, other than this Marconi's radio transmission, somebody was very much interested to amplify your signal. Who is that? Not Princess, only on the electrical side. Somebody was in the electronic side. Somebody was on the signal side. Who is the company? It's called Bell Laboratories. Graham Bell is the one who invented the telephone. So Marconi has did wireless transmission, whereas Graham Bell did the wired transmission. When you did a wired transmission, the thing was when I transferred a long distance, the signals was really very low here. So they have every receiving place, they have to amplify the signal. So they thought, well, it's boring. This vacuum tube I have to use, that's a very big one. The vacuum tube is as big as this much, this big. I'll bring it next time I have a very big. And also that requires, the heater requires 115 watts, 15 volts. And it will be very hot. You have to see that those radios, those days, we are never allowed to touch. My grandfather will open the radio. We have to sit about 10 feet away from that. Every in the evening, 7 o'clock, they will say, what is it, Volchitram, we don't know TV now. We have never seen a TV. TV we have seen only at the, I saw my computer, first computer itself, when I finished went to Yamtech. I have never seen a computer even during my engineering phase. I expect first my program was touch screen. So, this again, those days are very different. I applied for a phone in 91, when I started the company in 92. I applied for a phone, landline to BSNL. I had to wait for 3 years to get a phone connection. I have to wait for 3 years. My business cannot run. I have to have an arrangement with my neighbor shop. Hey, every call comes, I will pay you 5 rupees. Every call comes, I have to pay. Every second I have to call to US, I have to pay in all my bus will drive if I have to call somebody in US. So that is the kind of thing. So you will never imagine what things have changed in the last 30 years. Not even 30 years, I am talking about 20 years, 92, 93 I am talking about my company here. So that's the days. So then what happened? The Bell Laboratories is doing a lot of research on that. How to do the thing. 3 people. One is called Scott King, Gordon and Godman. There were 3 people, Godman, Gordon and Scott King were working on a product which requires very low power. They know that I'm doing.